If you recall from Monday, seems like years ago, we had the equation of an ellipse standard form has this structure, x minus h parentheses squared over a squared plus parentheses y minus k parentheses squared over b squared equals 1. That's our standard form of the equation of ellipse. And the center is h comma k. And then A is how far we go right and left to get to a vertex. There's two vertices left and right. And B is how far we go up and down to get to the two other vertices. An ellipse has 4 vertices, 2 horizontal, 2 vertical vertices that are equidistant from the center. Same distance left and right, same distance up and down. A and B being the square roots of the number under x and under y. X goes left to right, A determines left to right, Y goes up, down, B determines up, down. So it's pretty straightforward as far as the structure is concerned. The other thing we need is 2 foci. And depending on the value of A and B, if A is bigger than B, C squared equals A squared minus B squared. And you're going to move C left and right to get to 2 foci. If B is bigger than A, then C squared equals B squared minus A squared, and you're going to move C up and down to get to the foci. So these are the 2 scenarios for C. Depends on the values of A and B. The foci always lie on the major axis, the longer axis. If A is bigger than B, the horizontal axis is longer, so C has to go left and right on the horizontal axis. If the vertical axis is bigger, because B is bigger, C wants to live on the vertical axis because that's the major axis. All right? And C is the focal length. So the 2 foci that we're trying to get are going to be C left and right from the center. So in general, the process here, find out HK, A, B, and C, plot HK, move left and right A, move up and down B, and either move left and right or up and down C depending on which axis is bigger. Then connect the 4 vertices, those will be the 4 outside points, and then you move on to the next problem. Right? When the problems are written in standard form, these problems take about 2 minutes or less depending on your art ability. If you're a very good artist, it might take you 1 minute and 43 seconds because you can draw your ellipse quicker than other people and it looks pretty. Those of us who are artistically challenged, it takes an extra 17 seconds to get the ellipse looking prettier. So, all right. So if we take a look at example 3, graph the ellipse x minus 2 squared over 9 plus y plus 3 squared over 4 equals 1. You'll notice we have our nice little standard form going on right here. It says be sure to include center 2 foci, 4 vertices on the graph. So when we graph it, we're going to have 7 total points every single time we do this. First thing to do is establish what h and k are. And h and k are just like h and k were in the other 2 types of conic sections. The parabolas, x minus h, y minus k, change the sign with x and change the sign with y. With the circle, x minus h squared, y minus k squared, change the letter with x for, or change the number with x for h and change the number with y for k. Same thing here. So the number with x here is negative 2, x minus 2, which means x equals positive 2. It says y plus 3, so k is negative 3. Always the opposite sign of the numbers with the letters x and y. So my center in this problem is going to be h comma k, in this case 2, negative 3. 2 right, 3 down, there's my center. Everything else I do for graphing this ellipse goes off of the center. That's my central point. Everything is going to go off of that. I can see, since a squared lives under the x squared object, this number here, whatever this number is a squared. So a squared is equal to 9, which means a is equal to the square root of 9, which is equal to 3. A tells me how far to go left and right to get to vertices. So I'm going to go 3 to the right to get a vertex, and 3 to the left to get a vertex. That's to the right and to the left of the center. I look up to my standard form again. The number underneath y squared is b squared, so b squared is equal to 4, which means b is equal to the square root of 4, which is 2. And b tells me how far to go up and down to get vertices. So the centers here, I go up 2 from the center to get a vertex, down 2 to get a vertex. I could actually connect the dots right away to get the ellipse, but I still need to draw the foci in there, so I'm going to do that before. Finally, I can look and see that what's bigger between these two numbers, 9 and 4? 9. So c squared is always the bigger number minus the smaller number. These are the squares up here. This is a squared, this is b squared, right? So back here where it says a squared minus b squared or b squared minus a squared and b squared are just the pieces of the problem, right? So if I'm looking at this, 9 minus 4, so c squared equals 5. You don't have to remember the specific formulas for each one. Just know it's the big one minus the small one because c squared has to equal a positive number. So if c squared is 5, c is going to equal the square root of 5, which is approximately 2.25 is what we got, or sorry, 2.24. 2.24 is what we got in the other class. Now c isn't always one way or the other. It's the same as the major axis. So I'm looking at these two numbers. I can see 3 is bigger than 2, right? The major axis is horizontal. I know that's major because that's a bigger number. That means that c is going to go left and right as well. Okay, you have to determine c's direction based on the bigger number between a and b. It always matches the bigger one. So we're going to go left and right 2.24 to get vertices, or to get foci. So 2.24 to the right of center would be right about there. 2.24 to the left of center is right about there. And then I simply have to connect the dots, the 4 outside points, the vertices here to create the ellipse. Make it somewhat curvy. Just try and make it so it looks like it doesn't have straight lines. And that looks good enough to me. So every ellipse should look like that, an oval with 3 dots in between. All right. And again, the longer axis, you can see the longer axis is horizontal. The foci should sit on that longer axis every time, if you put them in the right spot. They should be inside the ellipse, on the longer axis.